Welcome to Coffee, Contractors, and Concrete, a podcast series focusing on all aspects of the surface preparation industry and brought to you by the industry experts at Buy Manufacturers Direct. Joining the podcast today is Substrate Technology President, Industry Patriarch, social media educator, and leading subject matter expert, Josh Jones. All right, Josh, now I'd like to talk about diamonds, and that's such a broad scope topic that we're just going to kind of briefly touch on different aspects. I'm going to throw out a couple keywords, and I'd like to get your definition of those terminologies. The first one is grit. So in the aspects of diamonds, what is grit?
Grit is just going to designate the size of the diamond crystal and the scratch that it's going to leave. The lower the number of the grit, that means the bigger the scratch. The higher the number of the grit, the smaller the scratch.
Matrix.
Matrix is what holds those diamond pieces, the individual crystals, together. It's the bond strength or the bonding material that holds it together. So when a diamond tool is observed, looked at, and a segment is seen and there's little sparkles in there, those are the diamond crystals, and everything that holds it together would be falling under the category or name of matrix.
Segment.
Segment would be the piece that I just referred to, which is a combination of the diamond crystals and the matrix. They can be seen as rectangular, they can be round, they can be square, they can be arrow, triangles, any number of shapes, because the way that they're put together in a mold, a mixture is made, the metals are combined as powders and then pressed into a mold. And whatever shape that mold is, that's what those segments would appear to be.
Bonds.
Bonds would be as was said about the matrix, bond would refer to how difficult it is for that matrix to be eroded away. If I use and there's a lot to the science of diamonds that is not known by people, because when it comes to the ingredients and the way that everything works together for life as well as performance, the secret is kept by a lot of the manufacturers, because it's very difficult to arrive at something that is usable in many different applications and therefore marketable and profitable. But when it comes to bonds, it's going to be a general term used to say the hardness of the matrix is a hard bond, which would essentially mean a hard bond is going to be more durable in an abrasive application. So hard bond, soft concrete, soft bond, hard concrete. But it's basically how easy is it to erode that mixture of matrix and diamonds to the point of wear.
PCD.
PCD is it's actually an acronym for polycrystalline diamond. PCDs were and still are, to my knowledge, are used in the petrochemical industry for drilling, literally drilling into the earth. It is a different style of diamond. It's has a different appearance and, of course, a different function. It is not a mixture of matrix and diamond chips or powders. It is a solid piece of diamond, industrial diamond, that is used for taking off coatings.
So are you saying that when we talk about diamonds generically, are we talking about real diamonds? Are we talking about synthetic diamonds, or a combination?
Both. There's diamonds that are made for synthetic diamonds that are made for industrial use. I mean, I don't know what the percentage is, but the way I understand it is the majority of diamonds that are in use today is for industrial uses. When it comes to natural diamonds, depending on the size, it is possible to still find certain size diamonds that are natural, which simply aren't good enough to be used as jewelry. They are the bigger sizes. Those are the natural diamonds. Whereas the synthetic diamonds, because of the needs of the diamonds to fracture and cut a certain way, they have to be engineered, because natural diamonds at certain sizes are just too unpredictable. But when it comes to 16 grits and 30 grit diamonds, as far as I know, they're still using natural diamond that is essentially useless for anything else. And it works. It works as a general purpose lower grit diamond.
So correct me if I'm wrong. When I think of diamonds, I think of three primary applications. I'm thinking of like a PCD that is more used to remove glues and things off a concrete substrate to get that exposed concrete. Then you have the series of prep diamonds and polishing diamonds, being metal bond and resin, that are going to prep concrete either for some sort of coating or take it all the way up to a polish. And then the last one is a bush hammer, which is what we referred to in an earlier episode about is a number 4 CSP. It's going to leave you more of an aggressive type of surface. Can you, starting with the PCD and the scraping type diamonds, touch on that, and then let's move into the prep and the polishing diamonds.
Well, when it comes to PCD, the only place where I really think a PCD is appropriate, in my experience, is coating removal. Though I've heard people say that it can take off certain concrete toppings, it can do adhesive removal. I've heard any number of things that a PCD can do. My experience is a PCD is used to take off a resinous coating, whether it be a 1/4 inch, an 1/8 inch, or 20 mils. A PCD, in my experience, is just going to be used to take those coatings off, and that's it.
Okay, so let's move on to metal bond diamonds. When would you use it? What's it used for? What are the most common?
Metal bond diamonds would be the ones that would be falling under the category of a CSP2. That would be the one that is going to be, it depends on the manufacturer and the different grit designations, but anywhere between a 16 and a 70 grit metal bond diamond is going to give me what I would call a CSP2. Anything finer, I'm starting to move into the honing side, something that would be more on the polish side that has nothing to do with profile that a coating could use. So when I say metal bond diamonds, it could be those rectangular segments, it could be arrow segments, it could be square segments, but essentially it's it's going to be what diamond is, or what kind of diamond creates a CSP2. It'd be a metal bond diamond.
And that would be an application where you're putting down some sort of coating where you need to
Correct.
have a CSP2. If I want to polish, am I going straight from a metal bond into a polishing diamond or a resin bond diamond, or is there some sort of transitional diamond in between?
There are, I like to call them bridge step diamonds, hybrid diamonds, copper diamonds. I mean, any name will do. Essentially, it's a diamond step that connects from what we'll say is the preparation portion of the work to polish and the tools that actually provide the polish, the high refinement mechanical processing of the surface of the concrete to make it reflective. So to answer your question, between the metal bond and the resin bond, there is a copper or a hybrid, which is a little bit of both. And the reason being is the scratches I put in the floor with a metal bond versus and they're still scratches, but when I scratch a floor with a polishing pad, despite it shining, it's still a very fine scratch. That bridge step, the step that connects those two so that I can go from aggressive, chalky, white floor to refined, reflective, dark floor, it's that bridge step, that copper, that makes it possible to make the transition from aggressive to fine.
So when you're talking about that polishing diamond or polishing pad, you're talking about a resin. Talk a little bit about that. Then I want to back up a little bit and talk about the importance of not skipping steps, because you are putting scratches in the floor. When you go from one step to the next, you're essentially removing the scratches that you put in the prior step. If you do skip, you're not going to have that capability to remove that scratch. Is that a fair assumption?
Correct. Yeah. The idea, the reason the sequence goes the way it does and the progression is the way it's designed per manufacturer of the system is that, let's say in the case of a 30 grit and a 70 grit in their relationship, a 30 grit puts in a deeper scratch than a 70. The 70, if it's matched to that 30 grit as a part of a system to remove and replace that scratch, then the 70 will come along and remove the 30 at the same time that it's removing, it's replacing it with a, let's say, smaller scratch or one that has less variation in depth. Because a scratch is still just a minor, just a very small peak and valley trough that's been cut into the floor. So if a 30 cuts a certain depth, peak and valley type of trough or scratch in a floor, a 70 grit is taking the high spot of the 30 off, the peak, and then cutting to the bottom of that 30's trough. Now the 70 that's done the work, it has a peak and a trough, but now there's less of a difference between the two. So as they start to get closer and closer, the floor, of course, then becomes more refined. But to answer your question, if I skip a step and a 70 is made to do that work to remove and replace that 30 grit, and I skip over the 70 and go to, let's say, a 120, I'm not going to get to the bottom of that 30 grit scratch because the 120 doesn't have enough aggressiveness to cut to the bottom of that trough. That's why the 70 is there. That's why it would be called specifically skipping a step. And skipping a step will definitely lead to results that are probably not sellable, and there's probably going to be scratches left in the floor that will have to be removed by starting over.
And correct me if I'm wrong, a lot of time that's not evident until you're several more steps in the process. All of a sudden, you
Correct.
start seeing scratches in the floor that were not properly removed 2 or 3 steps ago. So, in order to correct them, you're literally backing up and repeating the steps in the process.
Correct.
And that's got to be expensive and time consuming.
Yeah, because all the work that was done to the point at which it was observed that there's scratches in the floor, that was all wasted. There was no point. All that work has to be done over.
Touch a little bit about on resin diamonds. In a resin diamond or a polishing pad, are we still cutting at that point? Or are we just basically honing the existing floor?
No, it's still cutting. I mean, it's making waste, it's making dust. I mean, the easiest way to see if a polishing pad is doing anything, regardless of grit, is just remove the dust collection. Any dust that's coming out from under the machine will be the amount of dust that's being made during the process. It's much less dust. It's certainly not cutting nearly as aggressive as the lower grit tools, but without a doubt, there is still cutting taking place. That's how the floor is changing in appearance.
And talk a little bit. We'll touch on this in later episodes. The importance of still dust collection, even in the polishing process, because if you're leaving behind a residual dust, from my understanding, and you're just grinding that dust into the surface, which is affecting the aesthetics of the polish of the floor, correct?
Correct. Yeah. I mean, if the dust is not removed from the work area, it really has only one place to go, and that's under the pads and back into the floor.
And that may not be visual to the naked eye. It may not be visual until you think you're done and your floor just is not as reflective as you'd like it to be, or there's kind of a foggy or hazing effect to the floor.
Yeah, and that also does speak to the importance of cleaning the floor between steps, because if I'm running a, let's say, 400 grit resin pad, and then I move to an 800 grit resin pad and I haven't cleaned the floor between steps, there's a good chance that the amount of waste from the 400, though not as much as a metal, there is some waste still on the floor. If I don't wash the floor before the 800, I'm going to be regrinding the floor with a contaminant or a waste from the 400 that may hinder the ability of the 800 to provide the polish that it's supposed to. So not only am I worrying about the dust that might go into the air, it's the really the cross contamination from one step to the next because I didn't clean between the steps. So there's most definitely going to be dust left behind after every single step, and cleaning between steps, of course, will make it so it's possible so each step can do the work it's supposed to, as far as the results.
So let's talk about, we talked about earlier when we in CSP, to get a 4, we had talked about a bush hammer, which I still think is probably part of the diamond grinding process. What are bush hammers? When would I use them? What would I expect as a result from them? Kind of someone who doesn't know what a bush hammer is, give me the rudimentary education on what they are.
A bush hammer is actually carbide. It's not a diamond. It is definitely something that falls under surface preparation because it's preparing a surface for a coating. They are on a bearing setup so that they essentially roll across the floor rather than it be something that just drags from a fixed position like a diamond or a PCD. They are something that is on a bearing so that it rolls. But what it has on the outside edge of the tool itself are a bunch of little spikes, and those spikes are made of carbide. As they roll across the floor, those spikes are in a way similar to shot blasting, but not as directly. The spikes are picking away as they roll across the floor through pressure that's transferred through those spikes to break away small pieces of sand. So what it does is as it picks away that sand, just like a shot blaster with larger shot, it makes bigger divots. Bigger chunks are being removed, so therefore the holes in the resulting profile is greater than a CSP3. It's not really something that can be considered grinding because, of course, it's not diamond. And also, I will say it's very specialized. It's specialized to coatings as they specify for a CSP4, where it needs that kind of profile. I have heard people will suggest CSP for different coatings, but unless the coating says to do it, to me, it's not really worth the work. And I will also hear people say that bush hammers can remove underlayments, coatings, adhesives, and extra different topical materials. It's for that, for me, I'm usually going to be along the lines of the PCD, same thing, where it's used to make a profile because the coating says so. I would not use a bush hammer in lieu of a 30 grit diamond because I happen to have them, because the productivity and the result are two totally different things. And the way the tools work are different as well.
Take that into the next step of scarifying. Because what is the difference between a scarifier and using a bush hammer? And when would I choose one over the other?
It would be dependent upon the coating. If the coating specifies that it needs a CSP4, then there's no subjective decision on my part. I would use a bush hammer. If it requires a CSP5, then I would be using a scarifier. A scarifier is similar, but a scarifier is much more aggressive. And the reason being is because it is also a carbide cutter. The tip is actually a tungsten carbide cutter. But the difference with a scarifier is it's very similar to like a drum sander, like for wood floors. It is a drum of blades that is made to, instead of roll across the floor where a bush hammer rolls, this one literally accelerates and turns that drum and slams those tools into the floor from a vertical axis. So the bush hammers roll with pressure over them, but they roll those little spikes across the floor and they pick away at it. A scarifier, on the other hand, turns that roller almost on 90 degrees and then slams it into the surface of the concrete with those cutters. And what happens is, of course, the harder you hit it, the more weight above it, the bigger the chunk that falls out or falls away. So my profile, of course, then is even greater because the chunk I'm making in the concrete with the scarifier is a bigger piece than it is with the bush hammer. And so then, of course, the result is a void that's larger. That CSP5 is something that a coating might specify because whatever the coating is, whether it's a high tension product as it cures, it needs to grip the floor better than a CSP4 can provide. The tech data sheet explains what it needs. And as a contractor, I just give it the floor it needs, whatever specified, that's why I do it.
What other applications would a scarifier be a preferred method? Like a trip hazard or something like that. Can you expand on that a little bit?
Yeah, when it comes to a scarifier and the way that it works, as I just said, it slams that cutter into the floor and, of course, digs away at it much more aggressively than anything that's below that as far as the aggressiveness of the process or the process of surface prep. So if I have a trip hazard or I have an elevation inequality where two slabs meet at a joint, anywhere that there's an abrupt change in elevation in a slab of concrete or asphalt too, the scarifier is going to be the most aggressive way to reduce that elevation inequality. And the reason it's able to do that, or it's preferred, is because it is so aggressive. If I try to use a grinder to take down a half inch of concrete, it's going to take me longer with that precise method than it will with the more aggressive method of scarification to break that concrete in a controlled way, but to break that half inch of concrete away to change the elevation inequality so that it's no longer a tripping hazard or whatever it is that's problem it's causing, because those two pieces of adjacent concrete that's adjacent to one another are not meeting up. And so a scarifier is a great machine for that. Anywhere sidewalks have heaves because of roots, because of unstable conditions underneath a slab or a driveway where a tripping hazard could exist, anywhere that there are crowning joints inside construction projects with new concrete or existing, anywhere I want to take down a lot of concrete but not completely remove the slab, a scarifier is the fastest way to chop away the surface of the concrete.
And I think, like shot blasting and grinders, there are different size scarifiers with different power requirements that are capable of doing different levels of aggression. Is that true?
Yeah, absolutely. And here more than probably even compared to the other two, because the way the machine is slamming those cutters into the floor, the heavier it is and the more power it has, the less likely it is that when it directs that force to the concrete, if it's not heavy enough and it's not powerful enough, one, the drum won't hit as hard because the drum is constantly turning. So if it doesn't have the power to push through that impact, it's going to slow, and of course that'll hinder its ability to be aggressive. The weight is important too, because everybody knows if you hit concrete with a hammer, it's going to bounce up. Well, the heavier the scarifier is, when it hits that with the cutter, Well, the machine, if it doesn't have the weight, it's going to bounce off the floor and it won't have enough hitting power. So, um, without a doubt, the bigger and more powerful a scarifier is, of course, the more productive it's going to be.
And there's also, I think, a lot of different configurations of the tungsten carbide cutters underneath the drum that can provide a different profile as well.
Yeah, definitely. It's not really similar to diamonds, but because of the way that the tools hit the floor on the drum, the amount of cutters that are on each, the amount of the tungsten carbide tips that are on each cutter is going to influence how many times per cycle that cutter or that tool itself will actually chop away at the floor. I think a general rule to make a rough estimate of profile versus cutting tips, the higher the quantity of the tips that are tungsten carbide, the smoother the profile. If I have a 4 or 5, I think it's a 4, a 6, or an 8 point flail, which is the tool itself, the 4 point is going to leave a more aggressive profile than say an 8 or a 10, because it doesn't have the ability to roll as much as the one with more cutters. Or when it does roll, I'll say it this way: when it does roll, there's only 3 or 4 cutters available to do it in that whole flail. Well, on a 10 point, it's going to hit it more often, which means the more often it hits it, the more the force is broken up, and also going to affect the size of the profile or the damage that it does. It's its own science, I would say. From the standpoint of a contractor, it's something that, if I'm making a business of fixing elevation inequality issues, like I said, property managers would use it for fixing trip hazards and on sidewalks and in parking lots. Unless I'm really going to be getting into that kind of business, a scarifier is something that is pretty niche based on the product that is specifying its use.
This concludes episode 5 in a series of podcasts focusing on the basic principles of concrete surface preparation. Make sure to join us for episode 6, where we begin our discussion regarding chemical methods as they relate to surface preparation processes. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the Buy Manufacturers Direct YouTube channel. Simply visit the Buy Manufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.